So in this video we're going to look at absolute value functions. We'll start with the definition and then we'll do transformations like we did in that previous section. And then from there we'll solve equations and inequalities. And the inequalities are a little tricky, but we'll look at those when we get there. Starting off with the definition of an absolute value, you may remember just sort of in terms of pretty straightforward math, if we have the absolute value of 3, that would be 3. If we have the absolute value of -3, or whatever is in the absolute value, we take and make positive, and so that would also be 3. What that means practically in terms of a number line is when we're talking about the absolute value of 3 or -3, they're the same thing. The absolute value gives the distance from the origin, but it doesn't, the sign doesn't matter if we're going left or right. And so here, like when I put in 3 into the absolute value, if we thought this is a y equals, the output would be 3. If I put in -3 into the absolute value of x, the output would still be 3. And so we get this kind of V-shaped function. In terms of piecewise functions like we saw in the last section, you can define the absolute value as a piecewise of everything greater than or equal to 0 being y equals x. So we just get that 45-degree line right there. And everything on the other side, the negative side being -x, so that has a slope of -1, still intercepting at 0. So there's a definition for absolute value. And again, what it means is it's the distance from 0 on the number line. So whether it's 3 or -3, it's still 3 units. So this is going to be what we're going to call a parent function. So this has no transformations. This right here is just y equals absolute value x. And what we can do with that is like we did in the previous section on just transformations in general, is we can do all of our shifts, left, right, up, down, our stretches, our compresses, and our compressions, and reflections with this function. So let's take a look at, this one is actually right where we left off in the transformation section. So just as kind of a refresher, we are listing the transformations in the order in which they're applied. So if we thought about putting a value in for x, the first thing we would do is take away 2, and you might remember that -2 on the inside means it's going to go right 2, and so that is right there, letter C. And the next thing we would do is we would take the absolute value and then multiply that result by 5, so that's a stretch of 5, which is vertical stretch of by a factor of 5, that's F. And then lastly, we're going to shift it down 6, which is E. So same transformations we saw in the previous section, but now we actually have a function that we'll be working with. And we'll do this several more times during the quarter with different functions. This next question is asking us to write the equation for this absolute value. So for this, it's helpful to take a look and kind of see what happened to it. We have, change colors here. It's our regular one. Let me actually draw that in here. A regular parent function, not doing a very good job of drawing a straight line, but anyhow, it goes over 1, up 1, over 1, up 1. For this one right here, if you notice, see if I can zoom in a little bit more, it's going over 1 and down 2. So that means there's a reflection and there's a stretch of 2, because it used to be when I put in 1, I would get out 1. Now when I'm putting in that equivalent, I'm getting out twice as much, or 2, and it's opening down. So that tells me there's going to be a -2 in front of the absolute value. So that's our stretch and our reflection. Then we have our x. This shifted left 1, so that would be a plus 1 on the inside. And it shifted up 2, so it should be a plus 2 on the outside. For this one, looks like it's going over 2 and up 1. And with absolute value, you can really think of that stretch as a slope, as the new slope. So in here, the slope was, if I'm trading it on the right-hand side, it's opening down to a slope of -2 on this side, +2 on this side. but you can see the reflection, so that's why we have the negative. On this one, our slope would be, it's running 2 and going up 1. So in other words, when I used to put in 1, I would get out over 1 up 1. Now I'm only getting out over 1 up a half. And so that's going to be my stretch there. So here we'd have g of x, and then it's going to be 1/2 absolute value x, and this has been shifted right 2, so that'd be a -2 on the inside, and down 1, so a -1 on the outside. For these next ones, they're giving us a verbal description of what to graph. So we're going to do absolute value shifted left 5 and up 2. So starting at the origin, we're going to go count left 5 and then up 2, and that's the new vertex, that's the new pointy part. Absolute values are mercifully easy to draw, so it's just, if there's no stretch, it would just be over 1 up 1 over 1 up 1 on both sides forever. So that would look like that. For this one, we're supposed to reflect across the x-axis, shift right 6 and down 5. So let's go right 6, down 5 would put us right there. And then from there, we don't have a lot of room to draw it, but it would look just kind of like that. And then opening down because of the reflection. This one is stretched by a factor of 4. So if we think of our regular one, it would look kind of like that without any stretch on it, just plain old absolute value x. If I stretch this by a factor of 4, when I put in 1 instead of getting out 1, right, if I wrote the equation, it would be 4 absolute value x. So when I put in 1, it's 4 times 1 or 4 times as much. So when I put in 1, I'm going to get out 4 times as much y as I used to. And then I'll probably not do a good job of drawing this, but it should look something like that. And here, vertically compressed by a factor of 1/3. So again, let me draw kind of the parent function in here. So if we think of compressing this by 1/3, it's hard to, if I compress it by 1/3 right here, because again, this would look like y equals 1/3 absolute value x. If I put in 1, it's 1/3 of 1, and 1/3 is hard to graph. But if I put in 3, 1/3 of 3 would be 1, and that's actually really easy to graph. So if you have a fraction like that, I would think of it, I would put in the value of the denominator so that it comes out to a nice, clean, easy number for graphing. You can also think of this as having a slope of 1/3 and then negative 1/3 on this side. Either one of those versions works well. So make that a little smaller again. There we go. So this one's supposed to vertically compress by a factor of 1/4, reflect about the x-axis, shift left 1 and down 2. Okay, so let's go. So that 1/4, if again my regular one goes over 1 and up 1, this one's going to have a slope of 1/4, so it's going to go over 4 and up 1. So that's the shape that I'll draw, but I'll go ahead and go left 1 and down 2. So that's my new vertex, and then it's supposed to reflect across the x-axis, so that means it's going to open down. And that 1/4, we can think of it as a, oops, I started to think of the word rise, 1/4, we can think of it as rise and run. So we're going to run 4 and then rise 1, and in this case negative 1 because of the reflection. So this should look something like that.